Hi everyone, in this video we'll be talking about ionic compounds. Right, at the end of this lesson you should be able to link physical properties with structure and bonding in an ionic compound. You should also be able to state what type of structure is within an ionic compound, state the particles found in an ionic compound, state what bonding is present in an ionic compound, define what ionic bonding is, explain why ionic bondings have high melting points and high boiling points, and explain why ionic compounds cannot conduct electricity in solid state, but when I dissolve it in water or in molten state, it can conduct electricity. So we have previously found out that ionic compounds have these three very important physical properties. One, it is high melting and boiling point, or it is not volatile, right? It can conduct electricity only in aqueous and molten state and cannot conduct electricity in solid state. And what we have sort of inferred that because there is high melting and boiling point, there are actually strong attractive forces within the ionic compound. And because it can conduct electricity, right, that means there must be some sort of charged particle present. And in order to conduct electricity, I need this charged particle to be able to move, being mobile, right? However, I cannot conduct electricity in solid state, means that in solid state, this charged particle must be held together by attractive forces. So therefore, the inference seemed to make sense, right? And these inferences will inform us, right, about the structure of the ionic compound. So because you remember that there must be charged particle found in ionic compounds, so the particles found in ionic compounds are cations and anions, two different charged particles. And because there's cations and anions, right, there are two charged particles, therefore there will be an electrostatic force of attraction between them. And from our inferences, we can tell that this electrostatic force of attraction is actually very strong. So how do I describe what is the structure of an ionic compound? An ionic compound is described as a giant crystal lattice, meaning a very regular, as you can see in the diagram, right, arrangement of oppositely charged cations and anions held together by strong electrostatic forces of attraction. So all of these terms are very important, and the phrases are also very important as well. So if you look over here, there is one small little sodium chloride crystal. And then when I zoom in, I can see that there are actually sodium ions and chloride ions. And how it will look like is that you can see the last diagram on the right. It's a big three-dimensional shape over there. So ionic bonding, it's actually defined as the strong electrostatic attraction, right, between oppositely charged cations and anions. That's ionic bonding, right? And so for example, for sodium oxide, right, an ionic compound, it's a bonding between sodium ion and oxide ion. Magnesium chloride is the bonding between magnesium ion and chloride ion. So ionic compounds are usually, with some exceptions, formed between a metal and a non-metal, right? And ionic compounds usually can all dissolve in water, but not in organic solvent. So we are going to explain these three properties over here. And the arrangement of the explanations is exceptionally important, and you need to remember them. So firstly, how do we explain that magnesium bromide, an ionic compound, have high melting point? So we start with the therefore first. So therefore, magnesium bromide has a high melting point. And whenever something has a high melting point, it would mean that there's a lot of energy that is required to overcome these forces, right? Once I need a lot of energy, means that I have a high melting point, okay? And take note that you cannot use the word break here, you need to use the word overcome. So why is there a lot of energy needed or required to overcome? Because there are strong electrostatic forces of attraction between magnesium and bromide ions, right? Take note, these are ions and strong electrostatic forces of attraction. Okay, please remember this explanation. Right, the next explanation. Explain why sodium oxide, which is also an ionic compound, can conduct electricity in molten state. right? So what we're explaining, we're going to write in the therefore. So therefore, sodium oxide can conduct electricity in molten state. When something can conduct electricity, it would mean that there are mobile particles. However, we need to be specific. In ionic compounds, we need to call them mobile ions and not mobile particles, right? So, NS, there are mobile ions present. And why are there mobile ions present? It's because in the liquid state, sodium and oxide ions are able to slide over one another and move throughout the liquid. And because these ions can move throughout the liquid, there are mobile ions, moving ions, right? However, let's look at the explanation on why sodium oxide cannot conduct electricity in solid state, right? We are trying to explain this. So sodium oxide cannot conduct electricity in solid state. And as what I told you in the previous explanation, for something to conduct electricity, it needs to have mobile ions. So if it cannot conduct electricity, it will mean that there are no mobile ions present. Why are there no mobile ions present? Because in solid state, sodium and oxide ions are held in fixed positions. Alright, all these three explanations are exceptionally important for you to remember, and you need to remember the keywords that cannot be replaced. Right? So I hope you spend some time remembering them, practice, and you'll get better at it. Right? All the best. Bye-bye.